this is Durga again from IT University, one-stop shop to learn all the technologies. So at this time, as you guys know, this is the backup for the live audience. So I have already started the WebEx session. So we will go ahead and get started. Meanwhile, if you want to practice and if you don't have environment, you can sign up to labs.itversity.com with one of the plans of this, and then you can actually start preparing with the samples or examples I am providing as part of these free sessions, which are being streamed to YouTube. And if you have any questions, whether you sign up for the lab or not, feel free to post the questions on discuss.itversity.com, and we'll be glad to help you. That being said, let us get started. So we are in the middle of streaming analytics using Flume, Kafka, and Spark streaming. I have given an overview to begin with, and then I have covered Flume with different types of sources, different types of channels, and different types of sinks. We have concluded yesterday's session with HDFS and logger as sink, and I have given exercise about role parameters to play with those things and see the behavior. Okay, so I will provide the solution for it, and then highlight few important things with respect to HDFS, and then we'll move on. So here, if you go to my gist account, and my account is D Gadiraju. If you go to this link, there is a file, flume-logger-hdfs.conf. You can use this as solution for yesterday's exercise, which I have given while concluding the session. Okay, and here I have already explained the file type. File type is the one which needs to be used to save the data in text format. Let me copy it to Skype also. Okay, so file type will determine whether you want to save it in sequence file format or text file format. If you say data stream, it will save it in text file format. Otherwise, it will be sequence file format by default. And also, you can compress if you want. There is a third valid parameter where you can actually pass the compression related information. And then here, if you see the example, I have given roll interval as 120, which is seconds. So it is approximately 2 minutes. And roll size is 1 MB. So whenever what about others? Is it only with Raghu, or others also can't hear? Can you test? Okay, so probably he might have to relog in. Let's move on. So here I have given 2 minutes, 1 MB or 30, whichever happens first, it will immediately write from temp file into the regular file, and it will start a new temp file to stage the incoming data until one of these thresholds reach. So if it reaches 1 MB within 10 seconds, it will immediately it will immediately roll into a new file. Or even after 2 minutes, even if it does not generate much of data, still it will roll into a new file. Okay, so whatever happens first, it will trigger the rolling of the temp file into the regular file. And then I have mentioned about file prefix and file suffix. You can use this. So all the files will be prefixed with the retail, and all the files will be suffixed with .txt. And then if you look at this path, so I want to create directories for each day, separate directories for each day with a suffix, with common prefix, like in this case Flume example, and a suffix in YYYYMMDD format. Okay, so these are escape sequences which I have explained before closing the session yesterday. So if you go to Flume user guide and scroll down to sync HDFS, so here you see there are bunch of escape sequences. So if you say percentage host as part of the file name, you can file name or the directory structure, you can append host name. Okay, if you want to display time, you can give percentage t in milliseconds. In my case, the requirement is to display in YYYY hyphen mm hyphen dd format. So for YYYY, it is percentage capital Y. If you give percentage small y, it will be only 2-digit here. Okay, so I have given percentage capital Y here and hyphen percentage m hyphen percentage d. So for January, it will be January 1st, it will be 2017 hyphen 01 hyphen 01. For 31st, it will be 2017 hyphen 01 hyphen 31. So that's how a directory will be created for each day, and all the files will get into that. That will make our life easier to means as part of the technical specification, you have to follow certain standards for your directory names. Yeah. Okay, so these are the very important parameters when it comes to HDFS. So I have used the role-based parameters and also played with naming conventions. So now, if you use this and create an agent, the files will be generated under directory flume underscore example underscore YYY hyphen mm hyphen dd format. That will be directory structure, and the file name prefix will be retail, and then it will use the Unix timestamp dot txt as suffix. Okay, and don't give just txt. If you just give txt, it will only append txt at the end. If you want to make it as an extension, you have to give dot and then whatever it is. Okay, so you can test it out. I'm not going to run this again. I want to wrap up the Flume, but HDFS is very, very important from certification perspective. They ask Flume related questions. Most likely, they might emphasize quite a bit on HDFS. So just make sure you understand all the important parameters with respect to HDFS, and also you should be able to navigate through the documentation quickly and use it as part of the exam.
It created dot flume. That file channel folder is created. In file channel without data.
That is different. That is with respect to channel. If you give file as channel, data will be staged in the form of files and before it actually pushed into the sink. Okay, so you have source, you have channel, you have sink. Channel can be memory or final. If you give the memory, the data will be buffered into the memory for the channel. If you give file, it has to be staged onto the file system, and the default location is .flume in your home directory, and whatever you are saying, you can change it if you want. Okay, but those files are temporary. Whatever size you have mentioned, once those reach, it might delete or it might do whatever it needs to do behind the scenes. And then sync is different. Sync is the one where you persist the data permanently. This is sync. Okay, we are using a file channel also in this. Yes, and for that it will actually create the stage data in your home directory under .flume directory. That is the default location. If you want to give something else, you can give that also. Okay, so now let us get started with Kafka. Okay, so there are few challenges with respect to Flume. For example, in this case, we are trying to multiplex the data, right? When we try to multiplex the data, one to HDFS sync and the other to logger, for both the things we have channel. So these channels are completely isolated. Okay, and if you have 10 different targets where you have to copy the data to, you need to have 10 different channels. which means that it start using a lot more resources. Rather than if you have all the data pumped into one file structure, one data structure, and if all the subscribers can subscribe for the same and somehow keep run in sync without impacting other, that might be the better solution. So Kafka can solve that kind of problems. One of the problem Kafka solves is, instead of creating multiple channels like the way we are doing in Flume, we can have one queue, push data to that queue, and have as many subscribers as you want to get the data. Okay, so now we will get into Kafka. So again, you can just go to the official documentation of Kafka. I will provide theory. I will explain theory a little bit, and then we'll quickly get into the hands-on stuff. So just kafka.apache.org is the website for the Kafka documentation. So here, Kafka have three major modules. One is publish and subscribe. Publish is to publish the messages. Subscribe is to consume the messages. And then there is something called process, which is primarily to stream the data and do whatever you want in the streaming fashion. And then store, which is primarily to persist the data in databases or something else. Wherever you want to persist, you can use the store module. Okay, so here this example in this picture, Kafka topic is nothing but this one, where multiple publishers will publish the data and multiple subscribers will subscribe the data. And if someone want to do some stream processing in interactive fashion, they can use stream module, or they can use DB for storing the data. Kafka can directly connect to the database and store the data into the database also. So to facilitate all these things, let's say you have your own product and you want to use Kafka as a queue. Okay, then what you have to do, if your product has to, so you have multiple modules. One module has to publish the data, and the other module has to subscribe the data from that queue. So the module which want to publish the data has to use certain API and make certain API calls so that it can push the messages into the queue. And the module which want to subscribe the data has to implement the subscriber API, and it can fetch the data from the queue. So in some cases you have to do that. You might have to use the producer or consumer API, and then you have to process the data. For this purpose, they have categorized the APIs also into 4 different modules. One is producer API, second one is consumer API, third one is processing API, fourth one is I think connector API, streams API and connector API. So if you want to get into those details, you can explore these things, understand the API, and start developing the producers and consumers. Okay, and then so the topic, earlier picture, whatever you are seeing in the middle is nothing but a topic, and someone has to control the topic. Okay, and make sure that the messages are being pushed to topic and subscribed from the topic, and that component is called as broker. So there needs to be a broker which acts like a server and make sure that your topics is getting messages or publishing the messages. And if you get to the topic, it look like this. Okay, you can create the topic with partitions. So when you say, so the advantage of Kafka is the topic, which is nothing but queue. It can be distributed. You can create partitions so that it can be distributed, which means that you can have as many servers on which Kafka broker is running and manage these topics on multiple nodes. It can be replicated. So each topic will be replicated. Sorry, each partition of each topic will be replicated onto the multiple nodes, so that even if one of the server goes down, still you have the topics active on the other nodes, and publishers will be publishing the data, and subscribers will be subscribing the data, which gives lot of performance benefits and improves reliability quite a bit. So that is one of the major advantages of Kafka. It is distributed and it is much more reliable. So now if we say that let's say create a topic with 3 partitions, it will look like this. I don't know the underlying algorithm it uses, but I'm assuming that it could be hash algorithm. So using algorithm like hash or whatever it is, by default, it will start partitioning the data for each of the message it receives. And these messages are timestamped. So Kafka, when it actually saves the messages into the topic, will actually have the timestamp. It will have key, and then it will have value. Okay, and then producers write to the partitions if it is multi-partition topic, and consumers will start reading the data. And consumers, in tandem with broker, will keep track of the offset till the point each consumer have already consumed the data. So consumers are the ones which will be available, which will be aware of till what point it read the data. And when you actually create the topic, each file will be persisted for 2 days. After 2 days, it might go off. That is the default setting. If you want to increase, you can increase. So for 2 days, you will have, by default for 2 days, you will have the file. If you have to reprocess the messages going back by changing the offset to the earlier point in time, you can push your offset and you can reprocess the data.
Similar to CRC, like where we will doing the data frames like networking there.
I don't know about CRC. I don't know. Anyway, so that is how so topic life is. Sorry, each file. So topic is nothing but in a multi-partition topic, there can be multiple partitions, and each partition can be multiple files over its lifetime. Okay, but each file will be there for 2 days by default. Hence, consumers have time up to 2 days to consume the data. If something goes wrong, you can reprocess the data. You can take care of all whatever you can with that with the available data. Okay, so now let's get started. We'll get into the quick start. And here, when you are using your local machine, if you want to test Kafka, you can download. You can click on this link, download the tar file, and unzip it, and then go to the go to this directory. Okay, and first you need to start the zookeeper. The role of zookeeper is just a minute. Yes. Okay, so here we need zookeeper for Kafka because as I have mentioned, Kafka topics are distributed, partitioned, etc. And wherever you have a distributed environment, there has to be a coordinator which will make sure your environment is up and running all the time. It helps in failover, it helps in load balancing, etc. For that purpose, you need to start zookeeper. Don't emphasize a lot on zookeeper. Just think that it's a coordinator process to uh, to to make load balancing and high availability reality. Apart from that, as a developer, you don't need to break your head around zookeeper. It uses an algorithm called quorum algorithm. I'm also not 100% sure on that. Even though I'm also an administrator, I'm not bothered much about zookeeper. As long as administrators are good enough to troubleshoot the issue and fix it, you don't need to worry too much about zookeeper. Just remember that zookeeper is a coordinator process which will load balance and fault tolerant. That's it. So we need to have a zookeeper. If you want to set up Kafka, you have to have zookeeper, and then you have to start the Kafka server. So when you try to do this exercise on the lab, don't do these things. Don't download Kafka, don't start zookeeper, and don't try to start Kafka server. It is already there, and that you can confirm by going to Ambari. Log in with your lab user ID and password. And you have the Kafka service running. I have to troubleshoot this issue. One of the broker is not coming up, but as of now, broker is running on 2 nodes. But one of them it is not coming up. So it is only running on one, which is nn02.itversity.com. And also you need to understand the port number on which it is running. You can click on this configs, and this is the port number on which our Kafka broker is running. And Kafka broker does not deal with data directly. Consumers and publishers, consumers and publishers are the ones who will deal with the data, and the abstraction is at the topic level. They talk through topic, and topics are managed by broker. Okay. So if you are using lab, forget about step 1 and step 2. Directly you can go with step 3. Okay. So first you need to figure out where this script is. For example, if you log into the lab, and run Kafka topics.sh. It's saying command not found because I haven't updated the environment variables. Even in your case, it will be the same thing. So first you need to update the environment variable. How do you update the environment variable? First you need to know the location where Kafka is set up on the gateway node, and then you have to add it to your environment variable called path. You have to add the bin directory of your Kafka binaries, and then you can use these scripts. And these are purely to get started with Kafka. Typically, you don't create topics like this from the command line. You will be using tools such as Flume, whatever tool you are trying to integrate into Kafka, that should be capable enough to create the topics that are required. If you come up with your own module to integrate your application into Kafka, you have to come up with the program which will create topics for you. Okay, we should if you want to, you can use like this also, but this is not the effective way of doing it. So now I am changing it to my personal user where I have already updated the profile. So if you go to if I go to my profile file or bash profile, you see I have set up Kafka home to this location, and then I have updated my path to Kafka home/bin, which is nothing but user HDP 2.5.0.0-1245/Kafka. And whenever you touch path, make sure you concatenate to the existing one. If you just replace it, then other commands will not work. You have to be extremely careful. Okay, so you can add these 2 lines to these 2 lines to your bash profile before exporting the path. Once you update the path, you have to export. So I will add it in the Skype and also in the chat. Make sure you set up a path to this, and then you can give the you can use this command kafka-topics.sh create blah blah blah. And while creating, you have to tell your zookeeper location, zookeeper configuration. So how to get the zookeeper details? Again, go to Ambari. Don't ever try to start zookeeper or Kafka server on the cluster. It's already there. So go to Ambari and click on zookeeper and get the IP addresses and port numbers. These are the IP addresses on which zookeeper is running, and port number is this one, 2181. So you have to update this with those three. And then replication factor, if you want to have multiple copies of each partition, you can say replication factor as 2 or 3, whatever number you want to replicate into. It will help you in getting more reliability of your topics. Even if the server goes down, still one copy might be available on the other server. So there won't be any downtime for your module, which will be integrating data into Kafka or reading data from Kafka. And then partitions is primarily to distribute your topic onto multiple servers. Okay. And then you can give the topic name. So you can copy this to Sublime Text and change the zookeeper setting and also give a unique name, and you should be able to run it. So I already have it in my gist, so I will give the link to my gist gist URL, and then let me see where it is hiding. So you can also search here. Okay, it is all not. I thought it will be from only from my repository. Is there a way to search? Okay, here I can change all just. How to change this one? I will check later. There should be a way. Okay, anyway, let me go back to here. Okay, and then okay, I think I messed it up. Let me see. Yeah, now I got. Okay, here. Yeah, so this is how Kafka topic can be created. I will give you the link. Okay. So if you want, you can change this topic. Already, I think I have that one. So let me delete and recreate. Or let me create a new one. Okay. So W labs or WL Kafka DG. And now the topic is created. Okay. So topic means it's a queue which can accept the messages and which can pass the messages to the subscribers. Now we have to push the messages into this topic. If you want to list the topics, you can use the list command. List example is also here. If you just say -- list and then give the zookeeper address, it will give you all the topics. If you just want to get the one particular topic, I think you can give as many as you want using comma separated. Let me try this. Kafka DG. And you see Kafka DG and WL Kafka DG. Someone actually deleted it already, marked it for deletion. Okay. And then if you want to delete, you just have to use -- delete. If you want to produce the messages, you have to use the command called Kafka console producer.sh. And all these programs, Kafka console producer.sh, Kafka topics.sh, all these are part of this location. Okay, the bin under Kafka home. Unless you add the bin directly to the path, you will not be able to run these commands from anywhere. Otherwise, you have to give the fully qualified path. Okay, so for producing the topics, we have to give the broker list. Until here, we did not give the path to our broker. We are only giving the details about the zookeeper. So this Kafka command, I don't know, probably it might be talking internally with broker to create the topic. I'm not 100% sure, but it takes the zookeeper. These are all just handy scripts to test it out. Okay, I don't know internally what they are doing. Kafka topics.sh is primarily to create the topics, delete the topics, and list the topics. To push messages, they have provided a new program called Kafka console producer.sh, and it takes a parameter called broker list, and you have to give the IP address and port number. If you have multiple nodes on which broker is running, you just have to comma separate them and give the IP address and port number of all the brokers, and then you have to give the topic name. So in this case, topic name is WL Kafka DG.
What is the difference between isolation broker and duty?
See, this is a separate program we are running. That's what I'm explaining. Kafka topics.sh is one program. Kafka console producer.sh is another program. Okay. This program, our shell script, works through Zookeeper. Hence, we have to. It's the requirement. Internally, it might be talking to broker using the information from Zookeeper. I'm not 100% sure. It's up to that program what it is doing. What the syntax says. For if you want to generate messages and publish messages to the topic, use Kafka console producer.sh, and for that you have to give the broker list, not the Zookeeper. Why there is difference, I'm also not sure. Okay, it's the way they have developed. Okay, probably while pushing the messages, we have to go through broker, and while creating the topics, we might have to go through Zookeeper. I'm not 100% sure why there is.
You know creating the brokers anywhere? That's 6667 port.
That is set up.
Ambari somewhere.
That is set up through Ambari.
Okay.
Yeah, so that's what I have.
Because when you are pulling the Zookeeper details, you actually have the port number and all the instances, right? Same way, do we have anything?
Yeah. So if you go to Kafka, so these are the instances. This is Zookeeper information, and this is the listeners. Yeah, 6667.
Okay. I think that explains.
No, his question is different. Why we are using broker list to produce the messages and to create topics, delete topics, and all. We are talking with Zookeeper.
I think that goes back to something that you mentioned before. So Zookeeper handles all the
failover and
topic level. Messages are actually coming to brokers.
I don't understand. I don't understand the architecture completely. I need to revisit once more. Ideally, brokers should be managed by Zookeeper, and that's what is happening. That is 100% sure, because if you see,
topics, right?
no, broker. So this is the broker configuration. These are brokers, and when we configure the broker, we are giving the Zookeeper information, the IP address and port number. Okay, so once you add Kafka broker knows details about Zookeeper. Even Zookeeper will come to know about the broker, and broker is the one which is responsible at the topics level. So if you push the messages, so broker will not be in the way while pushing the messages or reading the messages, but broker is kind of a listener which will monitor the topics. It's a server which will monitor the topics and make sure that they are up and running all the time. They are accepting the messages or so there is a consumer and subscriber, right? So broker will work at the subscriber and consumer level. It will make sure that subscribers are pushing the messages and consumers are consuming the messages. And brokers are managed by Zookeeper. Okay. So when it comes to the only answer I can give why it is asking Zookeeper here and broker list here is that probably two developers developed these two programs, and he went through Zookeeper and this guy went through broker list.
Yeah, there's also another question. So if you go back to the configuration of Kafka, you already have the Zookeeper
yes.
connects, right?
Yeah.
So if any script that we're using within Kafka, do we really need to give those parameters? Because if you see your script,
that's what, either you have to give broker or you have to give Zookeeper. With Zookeeper, you can access broker details. With broker, you can access Zookeeper details. So two developers might have developed these two different scripts. One might be using Zookeeper and the other one might be using broker.
Are those parameters mandatory? So
Yes.
if you give broker list,
Yes. Either
or
you.
can they interchangeable? Can I use broker list? I don't know.
No, I don't think so.
Okay.
I don't think so. But you can give a try. You can go through these are all shell
Yeah,
scripts
shell
which are readable. We can go
Yeah,
through it.
I think broker is a general name
Yeah.
for producer.
No. Broker is not neither a producer nor a consumer. Broker is the one which will manage the topic.
Yeah, you get the answer.
Yeah. Okay. So here the question is primarily why we are using broker here and why we were using Zookeeper earlier. The only answer I can get is probably it is developed by two different developers. One guy might be using through Zookeeper and the guy might be accessing through broker. Okay, because Zookeeper and broker are integrated, and Zookeeper.
Yeah, exactly. So one URL could have done the.
Yeah.
They can get to the second parameter if they want. Also.
Yeah. So anyway, or there could be some other reason also.
Yeah.
So, but main thing is how to use this Kafka console producer to produce the messages. Topic name and broker list are mandatory parameters, and so we are testing Kafka by producing messages. Are you curious where these messages are hiding? Just go to broker list and check log directories configured in Kafka. Okay. You will see directories which are prefixed with topic name. Okay, so let's let's see it. So now where is our broker running? It's under nn02.itversity.com. Okay. So let's log into the nn02.itversity.com. You will not be able to access nn02.itversity.com. All of you will have access only to gateway node. But I will show where these messages will be hiding. So I'm going into nn02. And if you go back to the Kafka configuration, there is a parameter called log.das. And here I have configured these three locations on each of the server where the Kafka broker is running. So if you say ls-ltr/var, there is a directory called Kafka logs here. Similar is the case with HDP01 Kafka logs and HDP02 Kafka logs. Okay. If you go to that ls-ltr, so star will try to search everything and then subdirectory is Kafka logs. Okay. And then search for WL Kafka, that is my topic name, Kafka DG star, and hit enter. Okay.
These three are created for application.
No, 1 minute, wait. So let me show. Let me grab it first. Okay, so what you see, there is only one file. The reason there is only one file is because the partitions are one. I haven't specified more than one partition. And replication also one. If you have multiple nodes running broker, if I say replication has two, both the nodes will have one copy of same topic. As we have only, if we have partitions also two, each node will get two partitions of the same topic. As we have only given one partition, there is only one file, and directory, and the directory name starts with your topic name hyphen your partition index. So in this case, I have only one, hence it has only -0 as directory, and the location for that is it could be any directories because I have configured 3 different directories or mount points to store these log directories. okay, to store these log files. So it can go to anything depending upon the load balancing logic and all. So let us see where it have. ls-ltr. There is no WL Kafka. I think ls-ltr/hdp01. I think someone is pinging me here. Okay, hdp01 Kafka logs, and let's see. Yeah, here you see WL Kafka DG-0. Okay, why it is only in one directory? Because we have only given one partition. If we gave 3 partitions, probably it might have three directories, and they might go into 3 different file system. Why 3 different file system? It is all driven by this parameter in while setting up the Kafka. So whatever directories we give here, it will try to use those directories or mount points to store those log files. And now if you go to this location, hdp01 Kafka logs, and then go to WL Kafka DG-0 and see there is a log file and index file. We are primarily interested in the log file, and you can open the log file and see whatever I have typed is already queued into this topic or file which is created for the topic. Okay, so this is how it will work. So now you understand where the data is being stored, and now let us understand how to consume the data. So if you go back to my Git account, there is a console consumer script. Here it takes the broker list, but the parameter name is bootstrap server. Again, another term. It so I don't know. There might be some logic also, but I'm not 100% sure. Okay, I think eventually they are planning to change everything to bootstrap server. That's what I feel.
That makes sense because they have the reference to other zookeeper nodes. If you hit Kafka, you have everything else there.
Yeah.
So you don't have to get 2 different host nodes.
Yeah. Yeah, but for console consumer, we have to give both bootstrap server and zookeeper. I don't know why. Yeah. But I think eventually it will go this route. We have to pass both bootstrap server as well as zookeeper. I think that's the way it will go. I don't know why, but they might be thinking in that direction. There could be some valid reason. Okay, now let us see here. I'm pasting it here, and WL Kafka DG is the topic name, and then you can also say from beginning to get the data from the beginning. These are all 1 minute. Okay, I killed it. Accidentally I killed it. That's why. Anyway, let me start it again. Okay, I know the problem. So let me paste this. Let me leave it like this. Okay, and then let me copy this one and go to the other tab. And hit enter. Now you got the messages. We got all the messages. The first message, and accidentally I copied the consumer command also there, and then I copy pasted this one after starting the topic. So we got everything. And all these commands are just to explore, and you don't have many variations other than from beginning. It's purely to explore and validate that you are able to work with Kafka. And the main takeaway from here is the IP address and port number and the role of zookeeper. It's IP addresses and port numbers. If you got confused over there, it will be very tough to get it working. Okay. So now data we have validated by creating a simple topic and tested it by creating the messages, and also we have seen internals where the messages are being saved, and those are nothing but plain files which are created under the name of under the directory which have the name of your topic, and these topics are maintained by brokers, and brokers are maintained by Zookeeper for high availability and load balancing purposes. That being said, now that's it about Kafka. If you want to develop your custom custom plugins, you need to explore APIs further. You need to understand the interfaces, classes, etc., and you have to make sure you develop your modules to integrate with them. But 70% or 80% of the cases, you don't need to do that. There will be third-party plugins which you should be able to integrate and use it. And one of the classic use cases is to integrate with Flume and Spark. And we will see that. First, we'll start with Flume. So yesterday we have, I told you to finish the exercise because now we will be replacing the logger, which is logging the messages, to Kafka.
That work cannot be done by Kafka. Whatever Flume is doing.
No, Kafka is just a intermediate structure. If you, it might be able to do, but that's not its core functionality. That Kafka's core functionality is to stay in the middle and provide the flexibility to subscribers and consumers, either to push the data or sorry, publishers and subscribers, either to push or consume the data.
Because like that is like source producer and consumer is like sync. It's almost similar. So just I wanted to.
No, they are not similar. They are not similar. So there, consumer is source. That's correct. Okay, and yes, sync can be a queue. It can be database. It can be anything. So here, by using Kafka queue, you are creating a data structure where data can be pushed by certain set of sources and consumed by certain set of consumers. One of the classic example is master data management. Master data has to be used by many modules within the company. Okay, and what is master data? If it is a retail firm, the consumer's data is master data. His credit card information, his address, his telephone number, his demographics, his life events. These are all master data. And there are MDM systems where they will maintain this master data. And as and when there are updates in the master data, we want to update the downstream modules which will be using this master data, right? So immediately after saving into that, if we can push it into a queue and let the people consume, then you can broadcast to the all the modules easily, and you can use the application. So you can actually broadcast in real time, as and when changes happens in the source database. You can broadcast the master data to all the consumers within the organization. For that, if you use Kafka, it will abstract the subscribers without connecting to the database. They will be getting the data from the queue, and they do whatever they want within that as the data comes into that queue. Okay.
That's the guy I'm meeting now.
Yeah. Sure. So now let us start integrating with Flume. So when it comes to Flume, you can use Kafka as a source, as a channel, or as a sink. If it is a source, that means it will consume the messages from the topic. If it is channel, it will publish the messages to topic, and also it will consume the messages from the topic from the sink. And once sink can be anything, right? So it's the sink's or the channel responsibility is to not only so the source will be pushing messages to the Kafka topic, and target will be consuming messages from the Kafka topic. Or you can use Kafka also as a sink. So the if you go to the Flume architecture, for each and every sync, it is required to have a channel. Okay, so you cannot use one channel and you try to have it using try to consume the data using multiple syncs. That is not possible. Okay, so for that reason, Kafka as a channel has not much value. It doesn't have much value. Either it will be used as a sink or source. Mostly it will be used as sink. So you should know how to push data to Kafka topic using Flume as using it as a sink to the Flume. Okay, so what we will do, we will take the script which I have tested yesterday. Okay, and instead of pushing data to logger, we will actually push data to topic. Okay, so for that I will use again the topic name as Kafka DG. It is deleted, so I can use it. If I run into issues, it's a different story. So I'm going to WLabs SA. Okay, and then smp.conf. So let me add few parameters, whatever we have as part of the Flume agent here. So I will add all these things. This is channel, this is sync here. Percentage is A1 SMP. And I'm creating a subdirectory here. So whatever I have explained earlier, I'm just integrating that. WLabs SA. This is the directory, and then it will create the subdirectory with name Flume example and the timestamp in it. Okay. So here we have to change the logger to Kafka. And when it comes to using these plugins such as Kafka, you cannot just say Kafka. You have to give the fully qualified class name. Okay, and you need to make sure that appropriate jar file is integrated with Flume already. If the jar file is not added to Flume, then Flume will not understand from where the program needs to be executed. So you will get into class not found errors. Okay, but Kafka is supported from 1.5.2, and our version is 1.5.2. So we just need to use 1.5.2 Kafka related parameters here. So for that, instead of using Flume user guide of latest version, we will be using 1.5.2. Okay, and you can click on this 1.5.2, and here you have to go to the user guide. Okay. Okay, we have PDF, so we have to use this PDF. And in this Kafka it is not there here. Let me use 1.6.0. 1.5.2 I am not able to figure out. I think 1.6.0 is okay. Kafka. I think. Yeah. So this is how the Kafka sync needs to be configured. You have to give the type as Kafka sync broker list, the IP address and port number of all our brokers, and the topic name. If you don't give the topic name, it will try to create a topic by name default Flume topic. Okay, and if you go to one thing which you need to keep in mind is if you go to the latest Flume documentation and if you search for Kafka sync, the latest version they have bootstrap servers, not broker list. Okay, so make sure you have there could be some differences between the version which we are trying to set up and the latest version, and you have to act accordingly. Okay, so here I am saying type equal to this one, and then smp dot syncs dot. I will change the logger sync to Kafka sync in a moment. I will change it globally. Broker list equal to nn02.itversity.com colon 6667. Okay, and then I am say changing logger sync to Kafka sync. And then logger channel also I am changing the name to Kafka channel so that it won't be confusing. Okay. Now let's revisit the file. We have only one source, which is log source. We have two channels, Kafka channel and HDFS channel, and we have syncs, Kafka sync and HDFS sync. So log source and Kafka sync will be integrated with Kafka channel. Log source and HDFS sync will be integrated with HDFS channel. Okay, and yeah, and that's it. Very simple. It's not very complicated. Save it and come out. So one of the thing which you need to keep in mind is having the jar files as part of the Flume libraries. That the typical location for Hortonworks distribution is cd/user hdp the 2.5.0.0-1245. If you have multiple versions on the same machine, then you have to choose the appropriate version. I have only one, so it is 2.5.0.0.1245. And then we are talking about Flume. So Kafka has to be integrated to Flume. So you have to go to flume/lib and run ls-ltr with Kafka in it. And you see, because Flume and Kafka is integrated at source level, channel level, and sync level, you can see there is a Flume Kafka source, Flume Kafka sync, and Flume Kafka channel. If it is only sync, then you will only find one jar file with sync in them. So that's how you can extend the Flume. If you want to develop your own sync for whatever reason, you can develop the Java-based application, build the jar file, and add it here, and then start using the sync by giving the fully qualified class name as part of the type. As long as it satisfies the interfaces or abstract classes, you are good to go. Okay, so now I'm going back to my home directory and the location where I have the configuration file, and here I am saying Flume ng agent name smp conf home Digadraju. Here we just have to give the directory name. It's wlabs sa, and then conf file smp.conf and hit enter. Okay, did I add the topic name? I didn't add the topic name, so I have to kill this. It will create the Flume default topic. Okay, make sure you add the topic name also. And to add topic, you just have to say topic, and then Kafka DG. Okay, so it will create the directory with which have prefix of Kafka DG depending upon the replication and all those things. Most likely, if you see there is other Kafka properties, if you get to that, it could be on replication, partition, etc. So you have to go to the documentation and try to use the other parameters as and when it is required. Okay, so save it. Now start. Okay, there are exceptions. So first we need to, okay, this is with respect to file. We are using one of the channels as file. It throws exception in the beginning. Otherwise, you can see that data is being pushed to Kafka here. First, let me validate whether the data is going to HDFS. Then I will also validate whether data is actually, what is that? Actually getting into the Kafka topic also. So Hadoop fs-ls / user d Gadiraju, and what is the location I have given? WL labs SA. Flume is the subdirectory. No, not this one. Okay, I gave hi WL labs SA for some reason. Now you see there is a directory which have the prefix Flume months, for example, and then the time date. Okay, so we can actually see example underscore 201703-21 and hit enter. And you see now, okay, data is written every 30 seconds because roll interval is 30. If I give, I think I have given 120. No, let me see. Okay, roll count is 30. Whenever it receives 30 lines, it will roll. Okay, so that's why I think every 30 seconds it is generating approximately 30 messages. We can validate by saying Hadoop fs-cat wc-l. There are 22. Okay, I think there is some issue. Let me see. vifmp.const. Roll count is 30, roll size is 1 MB, and roll interval is 120, which means 2 minutes. Then why it is rolling out? Let me see Hadoop fs-ls.
Second one is after 2 minutes. Again, it is getting 30 messages. Second message is after 2 minutes. The third one is 30 count.
No. There are no 30. It's only 22. So I have to troubleshoot why it is generating like that. Roll count is 30. Roll interval is 120. Okay, let me see. File type data stream, roll interval 120, roll size 10 MB, roll count 30. Anyway, everything else is working, only this one is not working. I will troubleshoot later. I don't know why it is creating 2 files every minute. Okay, I will troubleshoot it later. Meanwhile, let us see whether it is actually pushing data to Kafka or not. So for that, what we have to do, either you can actually say Kafka consumer and try to read the data from the topic. So what we can do, we can go as a developer, that is the way you should troubleshoot. You should not try to log into the broker, the server where the broker is running. You have to check with the admins if you have to do that. You will not have access to all the nodes. So you can run this command, Kafka consumer. Okay, and hit enter. See that it's getting the data. I said from beginning, so it is actually getting the data from the beginning. Okay. So it is working. It is pulling for some time and then it is flushing the data out from the topic. So this is how you can validate that you are able to pushing you push the data to topic through Flume sync and make sure that you are getting the data. This is very important step. After integrating Kafka with Flume, you should validate. Okay, any questions here? So let me spend some time here and troubleshoot why I am getting new files every 30 seconds rather than 2 minutes. And then we will move forward. Just give me a few minutes. Also, if you want, I will right now it's 3:43, so I will give approximately 20 minutes time. You can try creating the Kafka topic, or if you need more time also, that is fine with me. Because we are a little bit ahead. Till tomorrow, I want to complete Spark streaming. Even if you take like half an hour, if you are able to do it, that is fine. 15 minutes I will give over about Spark streaming. Tomorrow we'll end the session with Spark streaming. We will expand this program itself to do a lot more stuff. So what I will recommend is, again, I use the same configuration file which we have so which is there as part of the gist. I'm pasting on the Skype. So use that only, and it has the capability to log into the logger and also to write the files into HDFS. Now you have to add the new topic Kafka to it. You have to change the logger sync to Kafka sync. Meanwhile, I will troubleshoot the issue.
Getting permission for NN01.
Yeah, you will not be able to connect to that. You will have access only to gateway node. I just connect to it to show how it look like. If you want to validate, you have to use that Kafka consumer program to make sure that you are able to consume the data from the topic which is already existing. I don't know what it is. Okay, I know the problem. I know the problem. I know the problem. I know the problem. Okay. Yeah, I think. Okay, data stream వర్క్ అవుతుంది. Okay, interesting. It worked earlier. I don't know why suddenly it stopped. Because is it because I'm using file channel? It should not be. How interval? fmp.sinks.hdfs sync.hdfs role equal to 100. Ah, now it is working. Okay, now it is working. I think it is because of the roll count. There was issue with roll count, I guess. Yeah, now it is working. So here I have to fix. Yeah, do the same thing.
That broker list port numbers.
Yeah, 6667. nn02.itversity.com colon 6667. Now it is working. Okay, now it is working, even the HDFS portion. I don't know why it was not working earlier.
Kafka.
Oh, you got it. Cool. So if you guys are interested this weekend, you can join. So we'll be covering purely Scala and Spark.
Is there any schedule of topics each day?
First day, mostly Scala. Probably I might get started with Spark. Second day, the complete core API, transformations and actions. Third day, it will be morning data frames, Spark SQL, etc. Evening, Spark streaming. Are you able to do that?
From yesterday,
What is that?
from yesterday I'm lagging with it.
Okay, okay. If you run into any issues, let me know. I will try to. So 10 more minutes. Vagrant. So 3 more minutes. So Himanshu is saying if I'm running Flume agent in CDH, how do I include the jar in? So Flume will be there automatically, even in Cloudera distribution. Most likely, they might add it to the cluster. Kafka sync jar. So Kafka is supported out of the box of Flume. So if Flume is there, automatically Kafka also will be there. If it is earlier version than 1.5.2 or 1.6, in that case, you just have to download the appropriate version of the jar files and you have to copy to the lib directory of the Flume, where first you need to identify the path where the Flume is actually deployed on the CDH cluster. And in that, you have to go to the lib directory and you have to copy the corresponding jar files to that location. You have to copy two things. One is Kafka jar, Kafka core jar, and also the Flume Kafka sync jar. Okay, so now let us start getting into Spark streaming. So we have seen Flume, we have seen Kafka, we have integrated the two. If you need a custom sync or custom if you need custom consumer or custom producer, then you have to understand the APIs and you have to write the programs. Okay, so Flume and Kafka is only to stream the data. We can't do much of analytics or filtering, aggregations, anything. We cannot process the data. We can just pass the data from several sources to several targets in more robust fashion. But as the data flows in, if you want to do some analytics, it is not possible with them. Hence, you have to use technologies like Storm, Flink, Spark streaming. Okay, so you can use one of these technologies and you can actually process the data. So what these technologies provide is all the transformations which we have seen on top of RDD, similar transformations can be applied on this data which is being streamed. So if you want to run analytics by queuing up last 30-minute worth of data, you can get the data to Spark using Kafka or Flume or both. Once you get data to the Spark, you can queue up the data without doing anything for whatever time period you want. And on that data, you can do whatever you want. You can also do lookup into external tables on that data, and you can do some advanced transformations or aggregations, whatever you want to do, you can achieve that. So the main point is, if you want to do any kind of aggregations, filtering, or any transformations, joins, any kind of stuff, anything that comes under data processing on the streaming data, you have to use tools like Spark streaming or Storm or Flink. As we are primarily talking about Spark, we'll focus on Spark streaming and see how we can achieve this. So let's go to the Spark programming guide. Let me take this call. Hello? Yeah, I'm in the middle of class. You have to wait until 4:30. You can come to the first floor, okay? Yeah. Bye. Okay, so you go to Spark programming guide of 1.6.2. And I think if you go to the overview, there should be a picture about all the modules in the Spark. Let me see, is it in the quick start? No, somewhere there should be a picture. Just give me a moment, okay? Just give me a moment. Somewhere there is a picture which will explain all the modules. Okay, let me go to one of my courses and show that picture. Okay. So here, if you go to Spark Programming Guide, Concepts and Architecture, I have a little bit of material over here. So this is the one, what I'm talking about. So if you see, there is this Spark core at the bottom, and then there are modules: Spark SQL, Spark Streaming, Machine Learning, Graphics, etc. We have seen the core Spark API and we have seen the Spark SQL. Now we are talking about Spark Streaming. So here, if you go back, if you go to the programming guides, you have the Spark programming guide at the top, and then for each module there is separate set of web pages. And for Spark streaming programming guide, you just have to click on Spark Streaming here, and it will take you to the documentation for Spark Streaming. Okay. So here, this is the picture. You can get data from Kafka, Flume, HDFS, Kinesis, Twitter, all these things, and get data into HDFS or database or dashboards. So you get the input data stream like this, and then you batch it. For example, if you say 60 seconds, every 60 seconds data will be queued, and you can actually process the data which you got in every 60 seconds. And there's a concept of windowing also, which we'll see tomorrow. And to get started, here is the sample program. Okay, you don't need to have the cluster. You can do it locally also. If you want to develop a sample Spark streaming program. And let me show you how to do that. So here I am opening the project W Labs. Okay, and first thing we need to do is we have to import, or we have to add the Spark streaming module. Okay, to get the information, you can go here and say Spark streaming 1.6.2 and hit enter, and you can get the Maven repository link here. You just have to copy this one and paste it to this. Sorry, this is not the correct one. We just have to use Spark streaming. We have to use Kafka if we want to read the data from Kafka. So I'm removing Kafka from here, and I'm using only Spark streaming. And you save it, and it will download the required modules to run the Spark streaming application local to your PC. But there are some drawbacks when you try to run local, especially in the local mode. You will not get the true behavior. So even for this, I will recommend you to develop the program. Even if it does not work locally, just ship it and try it on the cluster directly. Once you write the program and try to validate, just write it here, ship it to the cluster, and try to test it over there. Okay, so now the files are downloaded. I am going to this directory, right click on it, and then I'm creating a Scala class. And the program name I'm giving it as I think network word count. Network word count. And then we can say def main. Okay. So for this, first we need to import these two packages, Spark dot underscore will have Spark conf, and streaming we need to get the streaming context. Okay, and one more thing which you need to keep in mind is if you want to validate directly on the cluster. Okay, what is that?
Seems not Kafka. Streaming dot.
What is that?
Streaming dot.
No, streaming underscore only. Huh?
In progress.
This is correct. Okay, I think the build.sbt Spark streaming. So you can see here Spark Catalyst. Yeah, I think it did not. That's equal to org dot spark percentage spark underscore 2.10. Just give me a moment, I will figure it out. Network code count. And this is the one. Oh, interesting. Anyway, let me see. I can do one thing. Exit cd media projects. And now let me do SBT console. Okay. So the problem is there is a which program is that? Total revenue daily high. Okay. Let me try. So I will try it. If it does not work, we will see tomorrow. Okay, now let me import this one. and then dot tab. Yeah, it's coming. And dot underscore. And why it is not working here? Okay, let me delete this one. Where is delete? Okay, now I'm creating again Scala new Scala class soft type object network port count import arg.apache.spark dot underscore then import arg.apache.spark dot. How come it is not coming here? It says on W labs. W labs. So I will have a look at it tomorrow, okay? I think I have to troubleshoot this issue. Probably I might have to do BT clean. BT package. Okay, I will take care of it tomorrow. It will take some time to troubleshoot this issue. Okay then, thank you. So those who are online, thank you very much for joining the session. We will take it from here tomorrow. And if you like this video, please click on the like button. If you want to provide the feedback, please use the comment section of the video. And if you want to share with your friends, just click on share and share with your friends. And if you need environment, use labs.itversity.com. You might have already seen the prices. It is $14.95 for 31 days, $34.95 for 93 days, and $54.95 for 185 days. That being said, thank you. Bye.